now. So good morning, good afternoon, or good evening to everyone. Thanks for joining this instance of the Antrea community meeting. Today is Tuesday, June the 7th. For our friends in the West Coast, it's still Monday, June the 6th. And in the agenda for today, we have, I believe, a very interesting conversation with John Shong and Gavin about some update and developments regarding our Antrea CI. So I think you probably want to hear directly from the presenters and not from me. So I will hand it over to John Shong for discussing this topic. Please go ahead.
Thanks, Salvador. Can you see my screen?
Yes, we can. I can at least.
Okay, thanks. Hello, everyone. My name is Shu Yang, and today Zhengshen and I will share an introduction of our Jenkins CI migration from the public cloud to Antrea private lab. And for the agenda, I will introduce the motivation of the CI migration project and then move to the design overview. And we will introduce each key component in our CI pipeline. The future improvements will also be covered in today's topic. So I guess almost everyone in Antrea community has used our Jenkins CI by leaving a trigger phrase in their pull request. So the first question is, why should we migrate our Jenkins CI from the public cloud to the private lab? So first, the main reason we do job migration is to improve the stability and efficiency for our CI pipeline. I will give an example here. Previously, our CI on public cloud once had some account-related issues, but at that time, there's nothing we can do but only ask for the cloud team's help. So that means building a Jenkins pipeline that is fully managed by the Antrea CI team is very important. That's why we choose to do this job migration project for Jenkins CI pipeline. We don't want to only deploy the CI on the private lab, but it's very important for us to support this capacity in case we have issues on the public cloud. Okay, so let's move to the design overview. And from this diagram, you can see both CI workflow and our CI testbed situation. The nodes with purple color is our previous Jenkins host running on public cloud. The blue nodes, on the contrary, is our private testbed running on the Antrea private lab. And for previous usage, the user trigger test on the GitHub, and GitHub will send the webhook request directly to the Jenkins host, and Jenkins will run the CI task on the Bootstrap VM. There are basically two roles for the Bootstrap VM, which is building related images and creating a disposable cluster for CI tests. And by the way, we use the CPV as the deployment tool here to deploy cluster for both public and private Jenkins. And most of our CI job running on public cloud service before the migration. But since, as I said, we really need to support the private lab solution to improve the stability for the CI pipeline. So you can see the blue arrow shows our plan to support the job migration between these two Jenkins hosts. And after the job migration, most of our CI tasks run on the private lab. We add a SME service to handle the GitHub webhook, and then the SME client will receive the message from the service channel. And then Jenkins will also build images on the Bootstrap VM. But the difference is it needs to allocate IP for the control plane before deploying the CPV cluster, and then create a cluster with the CPV support and get the test results. Well, I understand that there are many components and you may have some question about them. So we have an introduction to these key components to show their unique function and why we use them in our CI pipeline. On this topic, I will introduce SMEE host local plugin and Jenkins job builder, and Zhengsheng will cover the cluster API, CAPV, and the CAPA topic. So let's start from the SMEE service. As I already mentioned, the public Jenkins can be accessed by GitHub from the public network. But for the private Jenkins, we don't want to expose the IP to the public network, which is not a secure solution. So we choose to use SMEE as a bridge to connect GitHub and Jenkins. The SMEE service uses channels to manage the webhook request from different websites. To implement our design, we need to create a channel for entry CI jobs on SMEE firstly, and then we run the SMEE client to subscribe this channel from Jenkins host. Also, we need to set up the same channel on GitHub settings. And then with this setup, the SMEE client can successfully receive the webhook request from GitHub and send it to the Jenkins with GitHub Builder plugin. So we can see on the right side, if the SME is available, you will have an active service with certain channel support for Jenkins. So basically, this is a secure way to receive a job trigger message from the public GitHub. And that's why SME is an important component for our CI private lab. And next is the IP management. After the Jenkins start to run the CI jobs on the Bootstrap, it need to allocate IP for control plane node of the new created CAPV cluster. The CAPV used to have a HA proxy feature, but it is deprecated now. So we have to allocate a static IP for control plane in the cluster control YAML, which is the YAML file you use to deploy the CAPV cluster. So to implement this design, we need an IPAM program to manage the IP address from the IP pool. So finally, we choose to use the host local plugin from the CNI project. It's very convenient for us to both allocate and release IP with this plugin support. And for the IPAM plugin itself, it's just like a key value store, to add and delete entries from user. And you can see the basic command for this plugin on the right side. It's only add and delete IP. And also it provides a JSON file that you can use JSON file to define the IP range, a subset and other configurations. And for the container ID parameters, we use the Jenkins job ID to share the same namespace with the CAPV. And since they have the same ID, it makes it easier to release IP after we destroy the CAPV clusters. So before we run the CI test, we need to migrate the Jenkins job as well. The Jenkins provides us a tool called the Jenkins Job Builder, or the JJB. It supports to verify and upload the Jenkins job from the YAML file, which is very useful for us to restore the migration job quickly. And you can keep your job description in human readable text format. It also has a flexible template system. So creating many similar configured job is easy. Just as you see on the right side, we have a job template YAML, which can define a template for multiple jobs. And when you define a template, you create jobs with a project definition. The variables in the job template will depend on what is supplied in the project YAML. And the macros YAML also used in the job description for Jenkins builders. This allows you to create complex actions in your job action. The JJB has more job fields that can be used to define your CI tasks, but we will not cover all of them today. So overall, the JJB can verify and restore the Jenkins job efficiently for updates and migration in our CI pipeline. And when you set up, you will find your Jenkins job in the console. So here is our current job migration status. You can see the Antrea E2E conformance and network policy job has been migrated to the private lab. They have been running on for several months on our private lab. So I think some of you may be curious how the what is CAPV. So the cluster API and the CAPV is very important for us to create the new cluster. And the next junction will share more detailed information for you about how cluster API works and its support on both vSphere and AWS. Thank you.
Thanks, Chuyang. Maybe let me share my screen. Yeah. Okay. So I'm sharing my screen and I'm on this cluster API page. And I hope the screen is visible. So I will continue. So thanks, Chuyang, for introducing the Jenkins migration. And note that actually the cluster API, the SMEE, the Jenkins Job Builder, and the IP allocation, these technologies are also used by Thea project. And this project, the tooling we are using are so efficient. So this helps us set up Thea CI in a very short time. So I will now introduce the cluster API and the cluster API vSphere provider and the AWS provider, and also introduce how we are using them in our CI. So what is cluster API? So Antrea needs to be tested. As we know, we have Khan cluster in GitHub, but that is not a realistic Kubernetes cluster. And if you want to do, for example, IPAN test or Prometheus test or some more test which needs to generate real traffic, Khan cluster is kind of limited, and the memory and the CPU and the storage are limited. So if we really want to do some more practical tests, we want to test it on real Kubernetes clusters. And then the problem is that how can we reliably and quickly deploy a Kubernetes cluster on demand for Antrea CI and for each PR? So the answer is cluster API. Cluster API is actually a bunch of CRDs for you to describe your Kubernetes cluster and how your Kubernetes cluster is like. For example, on the right, you see that there's some CRDs, actually CRs. You firstly define the cluster, and then you define your control planes and the kubeadmin config spec, and then you define the machine deployment, and then you need to specify how many workers in your machine deployment. So you know that in Kubernetes, you have deployment and pods. So you can specify how many pods you want to maintain in this deployment. So this is the same in the machine deployment. Suppose that you can have 3 control plane nodes, and then you can have a machine deployment with 3 replica. So you will have 3 worker nodes. So so this is actually a common standard for deploying Kubernetes on different IaaS providers. And each IaaS provider actually has to implement this cluster API. And as you know, in different IaaS providers, they offer different capabilities. For example, on AWS, you can leverage AWS VPC, and you can also leverage AWS volumes, Elastic volumes, and Elastic IP, and Elastic load balancer. So you on vSphere, we can leverage vSAN and the vSphere clone virtual machines and so on. So it also allows you to specify IaaS specific parameters, and this is the purpose of infrastructure reference. So usually we will create a template for clusters. For example, for vSphere, we create a template for vSphere and specify vSphere specific virtual machine parameters. For example, how many CPUs you want to assign to a workload worker node, and how many CPUs you want to assign to a control plane. And in AWS, you need to specify parameters for security groups and VPC and so on. So this is the very high level overview of Cluster API. And then let's go to specifically to Cluster API provider vSphere. So this is the current Cluster API provider we are using for Antrea CI. So it deploys Kubernetes on demand on vSphere cluster. And actually the workflow is like, firstly, we need to deploy a bootstrap cluster. And this cluster is usually a VM with a current cluster inside. And then we need to install, just ignore all these tags. And this is for the people who are not watching the recording and maybe they want to check the text. And after you deploy a current cluster, we will install the Cluster API components and the vSphere provider inside it. They are installed as a deployment inside your current cluster. And then we will configure the connection to vSphere API. And then you can define the Cluster API CRs on the current cluster. And on this current cluster, it will further deploy a management cluster for you. So one management cluster is needed. For example, if you want to manage 500 or 1,000 Kubernetes clusters and operate on them, a current cluster as a control point is maybe not powerful enough. So we use this bootstrap cluster to deploy a management cluster usually. And then your management cluster is powerful enough to contain, for example, 3 control plane nodes and 3 worker nodes. In fact, recently we deploy a scale out cluster for testing Antrea flow visibility about 300 nodes. So we use the formal management cluster for that purpose. And then from the management cluster, you can freely apply your Kubernetes Cluster API CRs, and it will really deploy the workload cluster for you. So it's a tortoise on tortoise. It's like this is a funny thing. But in our CI, actually, usually people just submit PRs in a not very so frequently. And then we usually manage dozens of clusters at the same time. So we don't need to need a real management cluster. We just use a current cluster with a bootstrap cluster node. So let me go to the next slide. So just now, Shuyang mentioned that we have an IP allocation method, and why that is needed for CAPV. I will talk about this. And to look at the real deployment in our CAPV on VMware Cloud and on our lab. So actually, we are just using a current bootstrap cluster. And on this current bootstrap cluster, we will allocate namespace for each job. So the workflow is like, firstly, you submit a PR on GitHub, and then you comment, add a comment on PR, for example, test something, or for example, test E2E. And then Jenkins subscribes these updates, this event, and it will schedule some jobs to the bootstrap cluster. And then the jobs are, for example, Antrea conformance for pull request, Antrea E2E for pull request. And for each job, each run, we will create a dedicated namespace. So you see that this box is a namespace inside your current cluster. And inside this namespace, we will create a Kubernetes cluster CRs according to our template in our Antrea CI code. So it's usually consists of 1 control plane node and 2 worker nodes. And all these clusters will be actually created on the vSphere. So vSphere will offer vSAN for the persistent storage and for the node volumes. And it will also offer indices logical network for your node network. So after that, your Kubernetes cluster, your Kubernetes virtual machines will be deployed, and then CAPV will run kubeadmin on the cluster nodes, and then to form a real Kubernetes cluster. And you know that all of the worker nodes and the control plane nodes are in the same L2 network. And the problem is that in vSphere, we don't have a built-in load balancer solution. So for example, if you have 3 control plane nodes, you need a load balancer solution for your virtual IP for your Kubernetes API server. So the solution in CAPV, as is an open source project, it doesn't want to rely on any commercial load balancer solution. So it's using the KubeWeave solution. KubeWeave is working on L2 mode, so it will do a leader election on your local Kubernetes API server and maintain a weep between the control plane node. So the L2 mode for KubeWeave requires that your weep is in the same CIDR of your node CIDR. So that's why we need to use a static IP for KubeWeave, and the rest of the nodes needs a DHCP. And NSX has the ability to configure all these networking capabilities for the node network and the static IP. So then you have your actually your clusters up, and then at this time there's no CNI in it. So in our Jenkins test code, we will build Antrea image on the Kant cluster because it has Docker in it, and then it will distribute images to our nodes, and then deploy Antrea YAML, and then run whatever test, for example, E3 test and conformance test on your Kubernetes cluster. And then after the test, it exports the logs and delete everything inside this namespace. So all of the resources on the underlay and on the vSphere physical cluster will be cleaned up very fast and cleanly. So it's a very convenient way for allocating a new Kubernetes cluster on demand. And this ensures that we don't reuse any Kubernetes. So any test doesn't have to consider, for example, clean up leftovers or any resources inside your Kubernetes, and it's convenient for us. And CAPV is also one of the ICE providers in the Tanzu Community Edition. And Tanzu Community Edition actually is a tool for you to deploy Kubernetes cluster and manage Kubernetes cluster on different ICE. So on vSphere, it's using CAPV, and on AWS, it's using a different bunch of technologies. So this is actually the topology and the overview of CAPV in our lab, and also on VMware Cloud. So do you have any questions related to this side? I guess no. So let me go to the next.
Sorry. Yeah. No, not on this slide. I had. Sorry, you can go ahead. Sorry, you can go ahead.
Okay. Yeah. So you do have a question, right?
Yeah, but I would like first to see to listen to all your presentation. Perhaps you will answer it.
Okay. Thanks. So let me introduce the cluster API provider AWS. So AWS is a public cloud provider. So so you know that we use the same template for the cluster API common part, but we need to use different resources for AWS infrastructure reference resources. So the cluster API if it deploys a cluster inside your AWS, you need to set up or have it set up some resources for you. So for the people who are not familiar with AWS, I will explain the resources first. So firstly, you need the VPC. It's a virtual private cloud, I think. So it's an isolation, and you can think of it, it's like it has a root router to the internet, and it has some subnets inside it. So it's like a virtual private data center for you. And then you can attach your AWS instance to the subnet. And then you can also have public IPs binded to your interfaces or to your interface. And then you can also have persistent volumes in AWS. And then you can assign the secret groups to your VMs, to your instances. And these secret groups will control the trafficking out. You can set allow rules or to allow some traffic in and out. So you can also have the Elastic load balancer in AWS. It's managed load balancer in AWS infrastructure. So you don't have to manage your own load balancer solution. And the load balancer can have public IP and public domain name. So this is the AWS overview. And if we have a work in progress pull request to add the AWS cluster API support in Antrea CI, and this is done by our intern in Beijing team, but his location in Shanghai. And the intern name is Sheng Kai, and he did a good job for this. And then what does this PR do? This PR will automatically deploy a cluster on your AWS, and it allows you to define your custom security groups on existing VPC. And this is what does this PR do. And the difference between the CAPV and the CAPA is that firstly, you need to create a VPC in advance, and then you need to create some subnet inside your VPC in advance and specify that to our CI script, so that if you create a cluster inside your current cluster, and they will be attached to the subnet and they'll be attached to the security groups. And you can have the CPA to automatically create everything for you. But in our situation, Antrea to test cases needs to SSH to control plane node and worker nodes. And then we also need to deploy or distribute Antrea images on these nodes. So we need SSH. And Antrea requires that some ports to be open for agent to connect to controller directly, and also for agent to maintain high availability cluster for egress. So all these need some special customization for security groups. So we have actually have a combination for this. And firstly, if we apply a cluster on the AWS, it will automatically create the load balancer for you and assign the public domain name for you. And it will automatically create some security groups for the load balancer. And then it creates the instances on the specified subnet. And then it will attach the instances to the custom security groups. So this is the major difference. And then the other parts are the same. We use the same code to deploy Antrea and the test. So the only part that is different is the IP management and the load balancer for the Kubernetes API and some security groups. So the cluster API perfectly hides the details between the different providers for us, and we just need to use the different cluster templates for different heights. And note that after your cluster is deployed, there's no entering. So it's not like EKS. So you know that EKS in AWS, your pod will get AWS Elastic interface and get the subnet IPs. But for the cluster API, it has no such support. So only your node gets the Elastic interface on the subnet. Your pod is still using the node IPAM controller. So this is perfect for us to test Antrea on it. And before we can make this thing work, there are some other work to do. Firstly, we need to finely tune the security groups. As I just mentioned, we need to open some ports, but for now, for the debugging purpose, actually we are opening every port, and then we will open only necessary port and find out if it works. And then we also want to remove the ELB or make it just the internal load balancer. This is because by default it opens your Kubernetes API to the internet, and this is not safe for us. And maybe we can also tune this security group to block access from the internet. And then we need to add job to schedule, add job to Jenkins, and then schedule some jobs to AWS. And for AWS, it's more, it costs more than our lab and then our VMware public cloud. So we will only schedule, for example, daily job for it. And this is because the vSphere provider has to use some older Kubernetes releases, and it's not releasing according to the Kubernetes cadence, in a very timely manner. But AWS release new Kubernetes releases in a very timely manner. So, for example, if you want to test the compatibility with Kubernetes 1.23, 24, we can probably rely on AWS for this. We can have a daily job or we can have a manual job before the release. So this is the introduction to CAPA. I guess there are a lot of stuff here. So if you have any question, I can answer for this slide.
Just have a quick one. So on AWS, I think we have one control panel node and 2 workloads.
Yeah,
our
we have one.
Okay.
Yeah.
Okay, got it.
We can also have multiple control panel nodes if that's necessary.
Sure, for the current test bed is just one control panel node and the 2 workloads.
Right.
And we don't run.
Also,
yeah, go ahead.
Please.
Do we also run the pods on the control panel node, or it's only for control panel?
I think it's just the standard Kubernetes cluster. So if your pod have some tolerations for running on control panel node, you can do that. So, so the control panel node is not managed by AWS. Actually, it's just a normal instance.
Sure.
So Antrea will be deployed on it. Yeah.
Understood. So we have 3 nodes in the cluster.
Right.
Okay, got it.
Okay, thanks. So another point is that for simplicity, I just draw one subnet. Actually, we can have multiple subnets for different clusters and for the Bootstrap VM. And this Bootstrap VM will be connected to Jenkins. And maybe let me go to the next slide. So the improvement for cluster API usage in CI. And firstly, we need to recover the CI in VMware Cloud. So Shuyang is already working on that. And then we want to use newer CPV images, and the current images are too old for the Kubernetes releases. And then we want to freely switch between the VMware Cloud and the lab. So there are some work to do for this, and we need to, for example, add some automation to disable some jobs on the VMware Cloud, and then do a Jenkins update and update all the jobs on the lab. Or if we want to switch back to VMware Cloud, we need to disable the jobs and just update the jobs in the VMware Cloud. Disable the jobs in the lab and update the jobs in VMware Cloud. And the benefit for running jobs inside VMware Cloud is that we can expose all of the logs to the GitHub, so you can see everything and what's failing and what's running, what's being deployed in your job, in your test. But in the lab, everything is is sensitive, so we don't want to expose any logs for now. And then we want to do some daily jobs on AWS and with recent Kubernetes releases. And I'm working on this with our intern. And then I also noticed that some of our tests, for example, IPAM multi-cluster, IPv6, and some other jobs require specific topologies from the underlay. And I think that the IPAM and the multi-cluster jobs probably can be moved to use the cluster API. For now, they are using actually pre-deployed Kubernetes clusters. And I think the core requirement for this job to work is to configure routing static routes on your underlay. And I think on NSX and on AWS VPC, we have the ability to configure static routing on the underlay. So if we migrate these jobs to cluster API, we can manage less predefined testbed, and we use the same technologies for more and more testing jobs. And another problem is that that recently we find a bug with, between KubeVip and the IPAM, Antrea flexible IPAM. And if we use actually the cluster API for IPAM testbed, we will discover this type of bug or confliction more timely. And then I also have idea. So that recently we have Fire project, and we also borrow some code from the Antrea project. And that the cluster API based on the cluster API code for Antrea and Fire are very actually almost the same. So I think maybe we can extract it to a common library and then just import that in Antrea and Fire. And this is in this way we just add the AWS support in one place, and it can be consumed by also Antrea and Fire. And maybe in future, we can add more providers to our cluster API CI. So we can also potentially leverage Tanzu Community Edition. And this is because it's essentially does the same thing we want, but it depends on if it can simplify our work for maintaining the underlying special topologies for our, for example, IPAN and multi-cluster jobs. So this is the improvements I planned in my mind. So I have a page for the references, and you can find out the project and the code for all of the tools we are using. All these are open source tools. And I want to thank you. And if there's any question for Shuyang and me, we can take.
Hello, just a quick question regarding the SMEE channel. So we're leveraging a third party for opening this channel. Do you think there is any security concern? Do we have to worry about any security concern and perhaps deploy our own SMEE instance, or is it perfectly okay even if we don't have any security guarantee?
Yeah, this is a very good question. So for now, we are just relying on the public SMEE, and this is because SMEE is developed by GitHub itself. The same guys developing GitHub, and it's also operated by GitHub guys on the Azure cloud. So I guess for now we can trust them, but since the Jenkins is running inside our lab, so if we don't trust them, it's an open source project. We can also have, for example, set up AWS VM to host the SME server and apply public certificate and the domain name for it. And we just maintain our own SME. But this will take more effort to maintain this. And for now, I don't want to invest in this way, but people can discuss.
Okay, sounds good. Thanks for the explanation.
No problem.
Hi, Johnson. This is Yang here. I have a question that I think is not that related to the presentation, but I do have a question on the CI. So essentially, I remember that at least for the last release, when people are pushing a bunch of PRs and having test stalls, one of the very annoying thing I found out about CI is that if in some cases you figure out something really little to change to the PR, and you force push to the PR a couple of times, and every time you do a test all, people needed to wait until the earlier jobs to finish, and the newer jobs are queued. So they needed to wait until all these in-flight tests, CIs are finished before the queued jobs can be executed. So I'm not sure that with the new SMEE service or whatnot, is there any logic you can implement it from the SMEE side, or maybe the GitHub side or the Jenkins side, which can do something like if on a specific PR there is a new change, then we sort of like tear down or stop the original build CI for that specific PR and just spawn up a new one. I don't know if it's as easy as just deleting the quote unquote namespace you mentioned for the CAPV that you spawned up and just create a new one, or it is more involved than that. This is my question.
Yeah, I got it. So unfortunately, in Jenkins, if we kill, just stop a job forcefully and just abort it, it has no chance for us to do any cleanup. So it relies on that, for example, your job finish is either successfully or failed, and then there is a catch up there's a catch for the exiting signal, and then it performs the cleanup. So, but your idea is very good, and I think we can maybe add some more comments support some more comments in the PR. For example, you want to abort something, you just abort, add a comment, abort something. And then we use the Jenkins API. And we also use the Class API to find out which jobs are running for your PRs. And then we kill those jobs. And then we clean up the namespaces. And I think this is the way to do it. So your user experience will be that you trigger test all, and then you push the new patch, and then you comment abort all or abort some particular job, and then you test all again.
If it's on private, then I probably won't have the job ID or something. But I guess something like abort all the job and the test all again, like something in those lines will be really great to have. And it will definitely speed up things a lot if people are having. Especially when people just fixing comments of the PR and having to wait a PR run that which have to run again is kind of like annoying.
Right. Okay. And then I think we can use the Jenkins API to fetch all of the jobs and detect that which jobs are related to this PR. And then once you abort all or stop all, it can find out the related jobs and kill them. I can investigate this, and I will investigate and follow up after the meeting.
Yeah, thank you. This is more of a feature request and rather than a question, I guess.
Thanks.
Well, I believe the community meeting is the right place for asking for new features. Okay, so thanks, Yang, for bringing this up. Is there any additional question for the presenters? Waiting a few more seconds. Okay, so I have a very stupid final question. And now that we are moving, starting to do jobs on AWS public cloud, do you made an estimate of, for instance, how much it will cost to run a CI job?
Yeah, and this is a very good question. So the budget I set for us is $200 US for a month. And I evaluated that each run will cost, for example, Antrea E2 will cost about $12 or $15. And then I can raise the budget because we have a really small cost on AWS. Usually it's less than $200. And I think I can accept, for example, $300 and $400. And actually, we have a very, very low cost on Google Cloud Platform and Azure. Usually, it's less than $2 on Azure and less than $20 on Google Platform. So if we extend our Class API to Azure or Google Platform, we can also distribute the workload to these eyes. So maybe it will further cut down our AWS costs.
Good. So as you wrote in the presentation, as you discussed in the presentation, we'll mostly use AWS for a daily job at the moment. Is that correct, considering our budget?
Yeah. So actually, the AWS costs more because it's expensive, and sometimes our ELK compatibility job will create some leftover clusters, and it's not cleaned up in a timely manner. So we will also need to fix this.
I see, but it's also promising that Azure seems to be much cheaper than AWS.
Yeah, Azure is very cheap. Yeah.
Good. Okay, thanks for this clarification. Okay, so it seems that there is no additional question. I'll probably just wait a few more seconds in case there is some there are some questions, and then
jobs which were like running in Jenkins before, would they like move to the new platform or just remain as they are, like we had the IPv6 before, etc.?
Pardon? Could you repeat the question again more slowly?
We previously had several jobs such as IPv6 running outside of the main platform. I'm guessing that this is because of the limitation of kind. Is that correct? I don't even remember why we were doing it. So would that be affected?
So there are some IPv6 and, for example, Windows jobs implemented in some private repository, and the testbed deployment code is also in private test repository. I want to actually open source this code because there's no sensitive information in it. It's just because when these jobs are implemented, we do it in an ugly way, and then we decided not to refactor and expose it to the public. It just works. But I think for the long term, we should refine all these code and contribute to the public entry repo, so people know what we are testing in IPv6 and in Windows.
Great, thanks.
No problem.
all right. So any final question? Perfect. It appears then it's all for this presentation. I would like to thank again the presenters for bringing up this presentation, most importantly for taking care of all these announcements on our CI framework. And now it's time for open discussion. Is there any other topic that you would like to bring up? Questions, grievance, complaints? Just waiting a few more seconds in case anyone has anything they would like to discuss. And I believe then therefore this is all for today. So I would like to thank everyone for joining. And thanks again to the presenter, and I wish everyone a good day, a good afternoon, or if you are on the West Coast, US West Coast, as usual, I wish you a good night. Thanks for joining, and see you again in 2 weeks' time.
Thank you, guys.
See you. Bye.
Bye-bye. Bye.